Welcome. So here we're doing vectors. Given that the line which passes through 1, 2 and 0 is perpendicular to the plane, which is 2x minus y plus 2z equal to 3. A, they say find the point of intersection, and B, they say find the distance from the point to the plane. Okay, that's fine. So what we're going to do here, first do like a quick sketch, because they want a plane and a point. So this will be our plane. So let's have our point here, and then we have this distance, and then we have a point here. If we name this x, y and z, and then this point is this one, which is 1, 2 and 0, and this plane, the plane is given by 2x minus 2y plus 2z equal to 3. Okay, fine. So they want us to find this point. The way you're going to do this is to know the property of a plane. We know that in a plane, this 2 minus 1 and 2 represents the normal vector. The normal vector is a vector which is perpendicular to the plane. So the normal vector is the same throughout the plane. So that means then even this point has that normal vector. So the normal vector here is 2 minus 1 and 2. So that means then from this point to this point we know the vector going there, and we have a point. So we can get a parametric equation of a line from this one using the n vector, which is 2 minus 1 and 2. So let's go. So I'm going to write a parametric equation for of the line. So we know that this point x, y, z, the equation of a plane is f or something, so will be that point 0 plus mu. This is the vector here, so it's 2 minus 1 and 2. That's fine. So that means then x corresponds to 1 plus 2 mu, and y corresponds to minus 1 minus mu, and z corresponds to 0 plus 2 mu. It's just like I'm just writing the parametric equation for the line. So we're fine with that. So what I'm going to do is to substitute these values to the plane equation, and then from there I find the value of mu. If we know the value of mu, we can simply substitute it back here, just that we're going to get the value of x, the value of y, and the value of z. So this is very simple. So using the equation of a plane, so we can say 2, what is x? X is 1 plus 2 mu. Then go to the other one, minus y is minus 1 minus mu. Then we go for z. Z is plus 2 into 0 plus 2 mu. So that's fine. So from here we just simplify here. so that's plus 1 plus mu. Okay, and then here we get plus 4 mu. That's fine. This everything here is equal to 3. Sorry, this is supposed to be 2. This is supposed to be 2 because we have the 2 there, right? So this is a 2. So from there we're going to sum up everything. So the mu, so we can get 9 mu equal to, this is a 3, this is a 2 and 2, take it to the other side, right? This is minus this one, and this one will cancel out, and we'll be left only with 3 here. So mu is equal to 1 over 3. That's fine. Then we substitute back to the equation now. Since we know that mu is equal to 1 over 3, we can say x will become 1 plus 2 over 1 over 3. Then we can say this is equal to 3. We take 2 there, and then add it to 1, which should become 5. So that we have 5 over 3. Do the same thing for y, minus y is equal to 2 minus 1 over 3. This is the same as 5 over 3, and z is equal to 0 minus 2 into 1 over 3, which gives me 2 over 3. That's fine. So we're done. So we have 5 over 3, 5 over 3, and then we have minus 2 over 3 as our point of intersection between the plane and the point. That's fine. That's fine. So like now let's go to the second part of the question, which wants the distance from point to the plane. Okay, if we look at they just want this distance. So here we can, this is very easy. We can easily use the distance formula because we have 2 points and we want the distance between them. That's fine. So other point is 1, 2, 0, the point that we are given here. So want the distance between these 2 points. That's fine. So the distance will just be equal to x minus x1 all squared plus y minus y1 all squared plus z minus z1 all squared. Then we simply do like simple substitution. So this will be 5 over 3 minus 1 squared plus 5 over 3 minus 2 squared plus 0 plus minus 3 minus 2 over 3 minus 0 all squared. So we're using this as our point A and then using this as our point B, trying to find the distance between A and B using the distance formula, and we're done. It's just a matter of simplifying this and we got the answer. So that's the distance between A and B. Thank you.